Thank you very much. Thank you very much for having me, and thank you very much for giving me the opportunity to talk about two topics which are, from my point of view as a professional cloud developer, super important nowadays. I come from a background where I have been doing enterprise development, so software development in the enterprise context, for quite a long time. And in the past, enterprises were very much focused on perimeter security. They were building these huge walls around their network, firewalls and things like that, and everything was fine. Inside of this firewall, everything was fine. We were best friends, very cozy, not much security. We trust everybody, and outside is a big, bad, Wild West internet. Nobody is allowed to come in. This has changed drastically over the last years. Nowadays, we develop solutions in the cloud. Therefore, the internet is our corporate network. We rely on so-called zero trust networking. We don't trust any network. Another very important thing here is that software more and more lives on public repositories. So it's not only at runtime where we live in the public internet. We also store our source code on the public internet. Think of GitHub and things like that. Given both things, it has become super important to professionally manage secrets. We need secrets in distributed systems. Well, we need them, but we can't get rid of them. I will show you that in a second. But somewhere we need secrets because we have services talking to each other and they somehow need to establish a trust relationship. And for that, we need some kinds of secrets, some kinds of security protocols for secret exchange. And Azure, if you develop solutions in Azure, has two super important mechanisms for handling secrets or for getting rid of secrets in the first place. And this is exactly what I'm going to talk about in the next 45 minutes. I will talk about Azure KeyVault and in particular Azure KeyVault in combination with Azure Managed Identity. I personally think that Azure Managed Identity is one of the most important features that every web developer should learn as soon as she or he begins writing web apps for Azure. Because you should never write a non-trivial web app and run it in Azure without using Managed Identity. Managed Identity is the go-to service whenever it comes to building distributed solutions. Do you want to access a SQL database from your web app? You use Managed Identity for that. Do you want to access a NoSQL blob storage on Azure from your web app? You'd want to use Managed Identity for that. Do you want to access some external API keys in KeyVault? You use Managed Identity to access KeyVault. So Managed Identity is really everywhere, and this is what you can expect in the next 45 minutes. A lot of information about KeyVault and Managed Identity, and because I said this will be an advanced session, I haven't prepared any slides. So everything is just code and just demo. I will walk you through all the different features of KeyVault. I will walk you through a lot of the capabilities of Managed Identity. You will see the Azure portal, you will see .NET 5 code, and so on and so on. Well, in sessions where you don't get any slides, let me move that to the side, it's always important to deliver some kind of takeaway. So you want to maybe take away the code, take the code with you and start playing with this code in your own environment. And therefore, I've put the demo that I'm going to show you in the next 45 minutes on GitHub. So if you would like to play around with this sample, check out this URL. It's my samples repository. I am very sorry, I put all my samples in there. It's not very structured. It has grown over time, but on the other hand, you get most of my samples exactly from there. And there I have this demo that you are going to see. You will more or less see this file throughout this demo. So check out this URL, download the C# file and start playing with it in your own Azure environment. Second thing, if you want to get in contact with me, well, that's pretty simple. Just go to my digital CV on reinerstropek.me. Here you see a short summary of what I do and who I am. And here on the right lower button, you see some important buttons here. Right lower corner, you see some important buttons here, especially important Twitter if you would like to get in contact through Twitter, LinkedIn if you want to stay in touch over LinkedIn, my GitHub account, and of course my YouTube channel, where you will find the recording of this session somewhere either today or tomorrow. There are a lot of videos up there. All of them are free, so check it out. I would be more than happy if I see you on my YouTube channel. Okay, with that, that's it. We will dive right into the first demos. So let's go to our Azure portal and put maybe this here so we can go through a little bit. I created a resource group here for this very demo, and in this resource group, let me zoom in a little bit. In this resource group, you see my KeyVault here. This is a KeyVault. KeyVault is essentially a safe place where you can store encryption and decryption keys, certificates, and secrets. This is what you can store here. Whenever you have to store either an encryption key, a certificate, or a secret, put it in KeyVault. Please, trust me, say with me, this is our motto that you take away from this course. We do not store secrets in plain text configuration files. This is a sin. You shouldn't do that. If you do that, you should feel bad. If you want to store secrets for your cloud applications, put them in KeyVault. If you need to encrypt or decrypt some plain text that you have to protect, I will show you a demo about that. Store the encryption keys in KeyVault. If you need, for whatever reason, a certificate for your web app, put it into KeyVault. By the way, one note on this one. This had been a pretty important feature of KeyVault, storing, for instance, SSL certificates in your KeyVault for your web app. However, that is no longer that important because nowadays you have managed certificates from Azure, so you rarely need to manage your own certificates anymore. But still, if you want to do that, KeyVault is the system that you definitely should check out. So this is what I created, and we'll take a look in a second. But what are the other things? Well, I have a storage account here, which I will use to demo some features regarding managed identity. I have my web app. I have pre-deployed the code that you will see, so we don't have to wait for Visual Studio or GitHub Actions to deploy my web app, so it's pre-deployed. And I have a virtual machine, which I will use. I will do some bash magic to show you what's going on behind the scenes. So this is essentially what you see here, and we will dive right into it by focusing on KeyVault. Let's check out what KeyVault is capable of doing. This is what KeyVault looks like in the Azure portal, and the first very important feature that I would like to show you, because it's brand new and it's currently in preview, is access control. Because that's the whole point of KeyVault. You store your secrets, encryption keys, certificates in KeyVault. But if you do that, you have to protect KeyVault properly from being accessed by people who don't have the permissions to access these secrets. Therefore, you need to somehow protect KeyVault. And this is done with access control. If you take a look at access policies in the past, or even now, if you want to do production deployment, you had been using Vault access policies. You see these one. Vault access policies were the access policies for accessing data in KeyVault. You could say who is allowed to access my KeyVault. So you had the control plane where you were capable of defining who is able to delete the KeyVault and to create new KeyVaults, and you had the data plane where you could say, okay, I want to create a new secret, I want to read a secret, and the data plane was managed through Vault access policies. But now we have a new capability here in KeyVault, and you should definitely check it out and use it. Azure Role-Based Access Control, RBAC, short RBAC, RBAC. RBAC comes into more and more services in Azure, and this is what you should use somewhen in the future. Azure Role-Based Access Control. That means that you define control plane and data plane security all here in access control. So let's check how I configured this one. Let's use this resource, and in this case, I, for instance, defined KeyVault as administrator privileges for two things here. On the one hand side, my web app, this is my demo app, and this will be relevant for managed identity. If you don't know yet what it means to grant access to an app, wait a second, you will see that in a second. And I granted access to myself, to my Azure Active Directory user, which is in fact a live ID, which is a guest in my Azure Active Directory. This is the reason why it says X here. Don't let that worry you. It's okay. It's correct like this. So I can define the access permissions on my KeyVault using RBAC. Or I will be able to, because this feature is currently in preview. Please take away this information from this session. That's new, and this is the way that it will be in the near future. I will not go into details about things like tagging and events and so on, because that is just the regular Azure stuff, and this is an advanced session, so I assume you are a little bit familiar with Azure. If not, you can easily read information about that in the documentation. Now let's talk about the most important three items here: keys, secrets, and certificates. And let's start right in the middle: secrets. Secrets are a good place for storing any kind of string-based secret. It could be a database connection string. It could be an API key. It could be some kind of password that you need to connect to any kind of protected system out there in the internet. Whatever you need to store. If you have a string and you would like to store it in a secret manner, store it in KeyVault. Let's check out how that works. We can say, I would like to create a secret. I do it manually. I will not upload a file or something like this. Let's say this is a live demo and enter the secret. Hello world from live demo, something like this. I can show you that if I go here. It should be able to make it visible. I thought it could, yeah, it says some text. Whatever you have to enter here, you can of course copy and paste it in. Another important feature of KeyVault is that you can set activation and expiration dates. I think the two settings are pretty self-explaining, so I don't need to go in any details. What you can also do, you can disable this secret if it is no longer used. If we create this guy here, it's stored, nothing special. Yeah, you can guess that's okay. And if I go in here, live demo, you will see another very important feature here. Here, you see that KeyVault stores the history of all your secrets. These versions can be accessed programmatically and of course through the portal. So if for whatever reason it was a bad idea to update the secret and you need for whatever reason the previous secret version, you can always get it from here. Also, speaking of deletion here, KeyVault has soft delete built in. So that means if you delete a version or a secret, it is not gone automatically. It's only soft deleted. You can prune the soft deleted secrets, so you can definitely get rid of it, but you need special privileges to do that. This has been built like that in order to prevent possible attackers to delete secrets that your application is relying on. So deletion is already pretty well protected. Okay, so we have secrets and we have different versions. Just like secrets, we can store keys. I'm talking RSA keys. I'm talking about encryption, decryption keys. So it's pretty simple to generate or import. I will not show you the import stuff. We can generate keys. And here you see the different encryption, the different key types and key sizes and so on. And again, activation, expiration date. I will show you a demo with an encryption key used in C# in a few minutes, okay? The important thing is that you can also generate encryption keys and import them into hardware security module protected keys. Please check the documentation if you need that extra level of security on top of your KeyVault. And last but not least, I could upload or generate certificates. Typically, you use some kinds of client certs or server certs, SSL certs, and so on. You can store them in KeyVault, and in your web app, you can get it from KeyVault. Okay, I have only 45 minutes today, and I have a lot to cover. So unfortunately, I don't have a certificate demo here. I stripped it because Well, nowadays Azure has managed certificates, so in many cases you do not need to maintain your own certificates anymore. You just check a box, yes, I want to have an SSL certificate for my web app, and Azure will give it to you, even if you have custom DNS. So therefore, many of you will no longer have the need to manually store some SSL cert from Let's Encrypt or wherever. Here, it's done automatically by Azure. I already talked about access policies. I will not go into the details anymore. This was the stuff with the RBAC. Now, another important one. Of course, we want to protect our secrets as much and as well as possible. And there is one feature in Azure which also has become pretty important, and especially when it comes to KeyVault. It's private endpoints. What does private endpoints mean? Imagine, let me draw a little bit, okay? I will zoom in here a little bit and let me do some drawing. Here you have the client. I'm very sorry, I cannot draw very good with my mouse, but I think you will get the point. This is your client, okay? And this is your nice little Azure environment. And in this Azure environment, you have a VNet, okay? So this is a VNet, a virtual network, and in this virtual network you have your web server somewhere here with your ASP.NET or whatever web app, okay? And the client here is accessing this one. Oops, I'm sorry, I didn't want to do that. Yes, this is what I wanted. This client accesses your, let's say, Azure App Service web app or web API here in this area. And this web API would like to use KeyVault privately. So we access KeyVault from this ASP.NET Core app. And this is what we essentially want. We want to have a protective border. You see it here, a virtual network where we can define network policies and firewalls and all this stuff. So nobody from outside can ever access our KeyVault directly. We don't want to do that. And this is exactly what private endpoints enable you. And if you ask me, this should be definitely your architecture if you create professional web applications in Azure. Create a virtual network. Put your app service either in the public internet and in the VNet or just inside the VNet. It depends. That would be a topic of another story. If you have questions on that, just get in touch with me. And then comes the important part. Create a KeyVault and add this KeyVault to your virtual network using a private endpoint, and then turn off access from the public internet. It should only be accessible from within your web app, because that gives you an extra level of security, an extra level of protection for your precious keys, secrets, and certificates. If you check out my YouTube channel, you will find in-depth presentations about how to use private endpoints, what they are in details, how they work with DNS, how they do their magic concerning local and public IP endpoints and so on. That would be, as I said, a topic of another session. I cannot go into details here. Check out my YouTube channel if you want to learn more about private endpoints. But you now hopefully understand how KeyVault is related to private endpoints and how both, correctly combined, can add a very important extra level of security for your web app. Okay, the rest down here are pretty much default Azure services that you know from all the other Azure services, so I'll not go into details. I would like now to go into code and show you what we can do with Azure KeyVault, okay? So let's do that. Here is my nice little application here. And the first thing that I would like to show you is this one. We will come to this get token in a second, okay? The first sample that I would like to show you is this one here. It says get secrets. And what this thing does, it's using the KeyVault SDK to access secrets programmatically. It's just an example. Of course, you can access your keys in the same way, your certificates in the same way, you can upload secrets and all the stuff. It just gives you an idea how you can work with KeyVault. The first thing that you create, here you see it, is you create a secret client because we are accessing secrets here. There is not just a secret client, there is also a keys client and a certs client and so on. But in this case, my demo is about secrets, so I create the secret client. Here, I specify the URI of my key vault. I called it key vault my secrets. The question is, how do you specify the secrets for accessing the secrets? How do you specify the secrets for accessing the key vault containing the secrets? Now we have a chicken egg problem, right? Somewhere we have to store the secrets to access key vault. Here, managed identity comes in. That will be our next topic, so bear with me for another few minutes. Currently, it's just Harry Potter programming. This here, is a little bit of fairy dust that we take and throw over the secret client, and magically it can access all our secrets. And I will show you, of course, what this magic is all about in a second. You see, you can nicely access things like properties of some secrets, and the API concept is always the same. What I really like about the new KeyVault API is that it plays very nicely with new C# language features, like for instance, await for each. So we can await for each the enumeration of secrets. So you see, the new KeyVault API makes really nice use of these new language features. In this little example here, I'm just putting together some secrets and give them back in JSON format. Of course, don't throw tomatoes at me. You should never, ever, and I have it here, do that in production, okay? This is a no-go. We store secrets and then we offer a web endpoint to get these secrets in plain text. We must not do that, of course, but here we are in a demo and I would like to prove that we can really access all the version information of secrets, all the secret values and things like that. So this is for demo only. Never do that at home. It could harm you, okay? By the way, those of you, that's just a sidestep. It has nothing to do with KeyVault, but maybe you are interested in. Have you ever seen a web API built like that in C#? That's all we need. Program.cs, doesn't that look great? Web application.create, use developer exception page, and then a bunch of map gets with some handler methods, and that's all. No controller, no dependency injection magic or something like this. Yeah, ASP.NET Core in the latest version learns a lot of new tricks, and this small sample, I tried out a new framework which is currently in experimentation state of some developers of the ASP.NET Core team. It's called Feather HTTP. Feather, like the feather of a bird. So it is a very, very lightweight framework to create small, really small web APIs or web applications. It is by far not ready for production use. It's just an experimental state. But if you wonder, hey, what is Rainer doing here? Is that ASP.NET? Have I missed something? No, you haven't. It's just an experiment. I like to use it for demos, and you can also give it a try. Feather HTTP is the name of the NuGet package. You need a separate NuGet feed for that, so it's really an experimentation state, but it's somewhat nice. So you see, I'm map getting here /secrets, and that will go right into this code here and will hopefully show us all the secrets. Let's give that a try. I will run the app, hit F5. It comes up just like a regular ASP.NET app. And here I would like to access secrets. Oh, I misspelled that. Secrets, that's it. And you see, here you see the demo secrets. And here you see my live demo here. That's exactly the secret that we created a few moments ago, okay? So you have seen what KeyVault is capable of doing. You have learned some new features, like for instance RBAC, about KeyVault, and you have seen, you got a glimpse of how to work with KeyVault with the KeyVault SDK, and that's for the moment all I want to show you about KeyVault. We will now switch gears and take a look at managed identity. But don't worry, we will come back to KeyVault because of course we will combine managed identity with KeyVault in order to remove this Harry Potter programming magic for how to authenticate with my KeyVault. Let me take a sip of water. Good. Managed identity. What is managed identity? Well, typically, you have a big problem if you would like to build a distributed system where you have your web app running in app services or in a VM, or in Kubernetes, or wherever you run your web APIs or web apps in Azure. And when this web API or web app wants to access some other PaaS service, for instance, let's say storage or SQL or KeyVault, or maybe your own backend API, managed identity works with your own backend APIs too. How do you do authentication? Well, in the past, what you would have properly done is you would create an Azure Active Directory service principal. This service principal would get either a client secret or a client certificate. Then you have to store this secret or certificate with your web app, hopefully in KeyVault. Then you read it from KeyVault and get a token from Azure Active Directory to access the backend API or storage engine that you would like to access. But as we all know, secrets shouldn't stay constant. They shouldn't stay unchanged over a longer period of time. So you will need to create some kind of magic script that goes over all your secrets, roll over your secrets, distribute these secrets again. So no secret should be unchanged for a very long time. Building such a system, deploying KeyVault and creating the secrets, creating the service principles, setting up all the permissions and all this stuff is a very time-consuming work. We have done it. I have been doing Azure work for over 10 years now, and we have an endless number of projects where we have built exactly that. And this time is over now with managed identity. Managed identity is, from a user's perspective, really trivial. If you want to opt into managed identity, all you need to do is you need to find this menu item identity here. I did that for the web app already, and flip this switch. Status on. Just on. And if you do that, Azure will automatically create a service principal for you. It will register an app for you and will assign the web app the permissions. And when the web app needs to access the backend system like storage or SQL, it can just ask Azure for a token. And because of the fact that the code is running in Azure, because the code is running inside of Azure with identity turned on, it's enough that Azure can understand and know that it is allowed to give an access token, an Azure Active Directory access token to this app, which it then can use in turn to go to the storage system like SQL, storage, KeyVault, or whatever. So managed identity means that your app in Azure gets its own app identity. It doesn't need a manually created service principal anymore. It doesn't need a user account in order to access other Azure resources. That's the whole idea of managed identity. And what about the secrets and the rollover process and all this stuff? All managed for you automatically. You do not need to care about that at all. Whenever you need access to a downstream service, you go to managed identity and say, I need a token for KeyVault, for storage, for whatever. You will get the token, you present the token to the storage, to the system that you want to access, and hopefully, if resource-based access control has been configured properly, you will be let in so you can access the system. When I say status on, I'm talking about this one, system assigned managed identity. If you would like to have more control over the app registrations and service principals that are created and maintained behind the scenes, then you switch to user-assigned managed identity. User-assigned managed identities are identities that you can use for multiple APIs or apps. They give you more control over what's going on behind the scenes. So if you are a pro and you really want to know what's going on and control every little detail, then you go for user-assigned. Otherwise, system-assigned is fine for simple or medium complex scenarios. So in my case, I've just said identity on. And then you can go to Azure role assignments here and you can assign additional roles to your app, not your user, your app. And in this case, I have set up a bunch of security assignments, role assignments for storage and for KeyVault. And that's the point. How do I access KeyVault with my precious secrets in it? With managed identity. How does that look like from a developer's perspective. You have already seen it here. All you need to do is whenever you create a secret client or a blob client, or when you use SQL client, you have to somehow create a default Azure credential instance. There are alternatives too. I will talk about them in a second. And these default Azure credentials do all the heavy lifting for you. You can add some additional properties, like what is the Azure Active Directory tenant that I'm working with. In my case, I have multiple, so I need to specify it here. And then that's all. The default Azure credential will do the following. It will check whether it is currently running in Visual Studio in the debugger. If it is, it will take the identity of you as a developer and get the token for you as a developer that is maintained in Visual Studio and use that one to access KeyVault, storage, whatever. If it can't find Visual Studio Debugger, it will try to use the token from Visual Studio Code if you've signed into Azure in Visual Studio Code. If it can't find Visual Studio Code credentials, it will use the currently signed in session from the Azure CLI that you might have open in Bash or CMD or PowerShell or whatever. So locally, if you press F5, it will use your developer credentials based on your individual system properties. But when it runs in the cloud, it will go to Azure Managed Identity and say, hey, Azure Managed Identity, give me a token because I would like to access, in this case, KeyVault. And then Azure will check the RBAC permissions and will give your application the proper access token. And I can prove that this really works because I, of course, have deployed this web app previously. Let me show you that. Here it is. Let's open this web app here and say, let's go to secrets. This will, This will now access KeyVault, but through my managed identity. And here you see it, it works very nice. I have never stored any kind of user or client certificate or secret with which my app in Azure could access KeyVault. There is no security setting in a config file. There is no secret. So we got rid of secrets in the first place. We don't need to manage them because we remove them out of the equation. And that's the important thing when it comes to managed identity. Now this is an advanced session, so let's dive a little bit deeper. I've created a second sample here that gives you a little bit more information about what is done in the background. Here you see a link to the documentation if you want to read the details of how to configure default Azure credentials. I will not read that for you because you can read the documentation on your own. The thing that I would like to show you is that we can use these default Azure credentials to get tokens manually. That's somewhat interesting because then we can check what's going on behind the scenes. This code that you see here, let me quickly get rid of this breakpoint so you can see it better. This code creates default Azure credentials and it gets an access token from managed identity for accessing storage. So I say, hey, Azure Managed Identity, I am an app. Please give me an access token for storage. And then Managed Identity will check whether the web app has identity turned on. It will check whether resource-based access control allows to give a storage access token to this app. And if it does, it gets the access token. And in this case, I'm just taking this token, decoding it with a JOT security token handler and writing the payload so we can take a look inside of the token back to the user. Again, you should never do that, obviously. Yeah, that's a security token. But for demo purposes, that's perfectly fine. Let me show you that directly out here in the wild. So I will say token to get the token. And here you see the token that we get. This token was given by managed identity. So in this case, I don't need KeyVault anymore. I don't have a secret for storage access. That was done automatically. It is for storage. You see the audience here. It was issued by Azure Active Directory. And do you see anywhere my name, Rainer Stropek, in this token? No, because it's not for Rainer. This is running in Azure, and therefore this token is only related to an app. That's the app identity, the managed identity of the app. So the resource-based access control credentials of the app apply, not of me as Rainer Stropek. So let me quickly run this demo here locally. We are good in time with 10 minutes. That looks very good. So let's go to token. Now this is running locally on my local machine. And guess what? The token looks entirely different. You see that one? That's me. So when I run exactly the same code with this default Azure credentials running on my local machine, it picked up my signed in credentials from Visual Studio because I'm running inside the Visual Studio debugger. I don't need to sign in again. And now for development environment, I can specify RBAC credentials for me as a developer. And for production environments, no human being needs any access to KeyVault. The only entity that is allowed to access production KeyVault is the app. Even the support engineers don't need permanent access to KeyVault. It's restricted to the app. Only in case of troubleshooting in case of troubleshooting processes, I temporarily grant access to the KeyVault to a human being, and then I revoke access to the human being again through the control plane API, and I roll over the secrets. That one is important because otherwise the human being could still maybe, I don't know, use the acquired credentials, tokens, whatever. I hope you got the idea how different it is running this code locally versus running this code in the cloud. Now you might ask yourself what's going on behind the scenes, and for that I have created another demo, and this time we are looking at a virtual machine. So I'm now in a virtual machine in Azure, and for this virtual machine, let me demo that. Here I have my virtual machine. I have also turned on identity. So as you can see, managed identity is not just something for web apps. Yes, it works with virtual machines. Yes, it works with Kubernetes. It's everywhere. So now I would like to access in my demo storage from a virtual machine, but without any SDK. I want to see what's going on behind the scenes. And I have prepared the necessary code here. The first one is a curl statement. So I do an HTTP GET request to an endpoint on the IP address, blah, 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 blah. And that is managed identity. This IP address is available from any system which has a managed identity. It's always the same IP address. It is available from web apps. It is available in Kubernetes. It is available from virtual machines. And I'm asking it for a token for storage. See that one? And then I'm taking the JSON request and parse out the access token. So if we are lucky, we get a JWT token. You see? This is the token that I got from managed identity. And now I can take this token and present this token when accessing storage. Let me quickly take this token and store this token in a variable, okay? So let's store this token in the variable token. I can make it visible by saying JWT.token, and it will show me, yes, that's the token you have seen before. Again, you see the app ID, and you see that it is for storage, and you see that it was given out by Azure Active Directory. And once I got that, I can go to storage. Let me copy that one. I can go to storage and ask it for a certain blob. You see that blob? This is not publicly accessible, but I can now present the token that I got from managed identity, and then I can access this private file, which is in fact an XML file, which I will talk about in a second why it is there and what's its goal. So as you can see, managed identity isn't fairy dust and Harry Potter. It's just a service, a REST API, which is available inside of Azure, where your app can go to and ask for tokens for specific audiences like storage, SQL, KeyVault, and so on and so on. This is working behind the scenes. Okay, I hope you could follow because I would like to wrap up and show you the last few demos, and then we have maybe 2 or 3 minutes for questions. I would like to come back to the KeyVault stuff again, because this talk is about managed identity and KeyVault. There is one feature which I must absolutely mention, and it's the possibility to store app settings in KeyVault and reference them through KeyVault references. Let me show you how this is done. If I go back to my web app, and if I take a look here at the configuration, I have a demo setting. This one, the KeyVault setting. And if you take a look, then here you see a very special beginning at Microsoft.KeyVault secret URI and so on. So this secret URI, or this at Microsoft.KeyVault here at the beginning of the setting, I will show you the whole setting here. Let me go here. Oops, this one. As you can see, this is just the version ID. There is no secret inside here. It's just the URL of the secret. This prefix here will make sure that app service will not take this literally, but we'll try to use managed identity to go to this KeyVault and read the setting from there. So if we try to access this one, I think I called it setting if I can remember it correctly. Yes, it says hello world, you see it here. But this is not hard-coded in my code. I'm just accessing the regular ASP.NET configuration settings. And this configuration now is a redirect to KeyVault and brings together managed identity and KeyVault at its best. Okay? So this is a very nice way of putting secrets in KeyVault without having to add manual code like you've seen before to your ASP.NET app. It's just the regular settings mechanism that you know from ASP.NET Core. If you want to read more, here is the link, and you can find this code on GitHub. Last but not least, my final demo. Data Protection API. I hope many of you know what I mean with Data Protection API of .NET Core. ASP.NET and .NET Core have a Data Protection API built in. It's a trivially simple API for protecting, means encrypting, and unprotecting means decrypting secrets that you need to encrypt and decrypt. The API is really trivial. Call protect and you get the encrypted version. Call unprotect and you get the plain text from an encrypted version. So if you need to store some kind of, let's say, cookie or anything like this, which travels through the client or something like this, use just these two functions and it just works. It's the Data Protection API of ASP.NET Core and .NET Core. And the thing that I want to clarify here is that this Data Protection API, which should be used in so many web apps out there, because so many web apps need to protect, need to encrypt and decrypt stuff, this works perfectly fine with KeyVault and Managed Identity, because all you have to do for the Data Protection API, you need to give it two things in Azure: a location for blob storage where it can store some XML data. This is exactly the XML file that you saw before, and a KeyVault with a key in it. That's an RSA key. That's an encryption key that I created up front. And then the .NET Data Protection API will use KeyVault to protect the XML file in blob storage, and everything, all of that will be used to protect and unprotect your data. So it becomes very simple to build a system where everything is stored securely in KeyVault. You don't have any kind of keys, no manually maintained service principals or whatever. By combining Data Protection API, KeyVault, and Managed Identity, you can build a system that you can easily make public through GitHub, for instance, because there are no secrets anymore. The secrets that exist, or the keys in this case, the encryption keys, are safely stored in KeyVault. And how do we access it? With Managed Identity, because there are no secrets anymore. This was my demo. This was what I wanted to show you, and I think I yeah, I managed to show you everything just in time, because if I take a look at the watch, it's 2:43. So we have a few minutes of time for questions. From my side, thank you very much for listening. I hope you learned something. And with that, I give it back to the moderator and ask whether there are any questions that I might need to answer. Thank you.